I had a question from a Calculus 2 student about 9.5, number 21. So, series can be tricky, okay? So unless it's something obvious, if you have a geometric series or something, you know, p-series, a lot of those are pretty obvious. But if you have a sticky series that you're having trouble with, my go-to method is always to write out a few terms, okay? So I haven't really looked at this yet, but what I'll do is I'll write out a few terms and then see if I can see some kind of a pattern, and that usually gets me started, okay? The thing with series is just like everything else, right? We learn our lesson from our friends the rabbits. You don't want to stare at something, okay? You don't want to sit there and stare at something, you know, like I live out here in the country and we have these rabbits and they come out at night and they sit there on the road and a truck comes and they just sit there and they stare at it and it doesn't end well, okay? So, you know, if you catch yourself staring at something, you need to quit that, you know, get out of the way, do something, yeah? So, don't want to stare at a series. You can always write out a few terms and that gets you moving, gets you going, right? Remember, problem solving is dynamic, so, you know, if you're not doing something, you're not solving the problem. So let's look at this thing, 9.5, number 21, and we'll see what we got. Okay. So we've got a sine function, and then a giant fraction. 2n minus 1, and we're multiplying that by pi over 2. Okay, so let's write out a few terms. Yes, so we've got n here. So we've got 1, 2, 3, 4. Now, how many terms do you have to write out? You know, it just depends how good you are. I usually have to write out a lot of them, all right? Okay, so what do we get? We get sine, right? 1, right? So 2 times 1 is 2. 2 minus 1 is 1 pi. So this is going to be pi over 2. Okay, this is a sum. Okay. So here we get sine, right? Okay, so 2 times 2 is 4. 4 minus 1 is 3. 3 pi over 2. Wait a minute, isn't this the formula for an odd number or something? This is the formula for an odd number. Okay, let's try 3, right? 2 times 3 is 6, minus 1 is 5. Yeah, we're going to get the odd numbers here, okay? Sine 5 pi over 2. Okay, so I think the next one is going to be sine 7 pi over 2. Let's see. 2 times 4 is 8. Yeah, so it's going to be sine 7 pi over 2. Okay, so I understand what this is going to be. This is just going to be, oh, and these are sum. This is the sum, right? So this is just going to be odd numbers, right? Odd numbers times pi over 2, basically. Okay, let's get some numbers. So let's look at our unit circle here. Okay, so here's 0. This is pi. This is pi over 2 sine. Sine pi over 2 is 1. Okay? Sine 3 pi over 2, that's here. 3 pi over 2, that's negative 1. 3 pi over 2, 4 pi over 2, 5 pi over 2, this is 1. 6 pi over 2, 7 pi over 2. Looks like all of the odd pi over 2s are going to be down here. Not all of them odd, but I mean like all of it, every other one. So it's negative. So it looks like this thing is just all a bunch of ones and zeros, right? It looks like this is basically what we've got, right? If we start out at n equals 1, we make this plus. So would this give us the exact same thing? So let's see, n equals 1. So 1 plus 1 is 2. So the first term would be positive, right? The second term would be 2 plus 1 would be 3. This would be negative. Yeah, this is what we've got. Okay. We can move this to 0. And get negative 1 to the n, I believe. Yeah, that'll do the exact same thing. That'll give us the exact same series, okay? Negative 1 to the 0 is 1, right? And then we've got negative 1 to the 1, which would be 1. Negative 1 squared, yeah, okay. So, yeah, this will give us the exact same series. This is a geometric series, okay? And R here is 1, right? So this thing is going to be divergent. This is actually a divergent geometric series. Now, remember that the criteria for a geometric series to converge or diverge is that the absolute value of R has to be strictly less than 1, okay? So this is for convergent geometric. So it's absolute value. So the fact that this thing is negative doesn't really tell us anything. Okay, so, you know, looks trigonometric. The terms are just a bunch of 1s, negative 1s, right? Looks like maybe 1, negative 1, 1 plus negative 1 is 0, right? 1 plus negative 1 is 0, yes? So it's all going to add and subtract out to 0, but remember, this thing goes to infinity, so there's always that last term, you know, that causes a problem. So this thing is a divergent geometric series. So if you have any further questions about any of these problems, it's good to see that you're doing them. I'm pretty happy about that. Send me an email, and I'll try to make a video.